Lesson 17.3 is initial value problems with calculator. The derivative of the function f is defined by f prime of x equals this trig function here. If f of 2 equals -6, then use a calculator to find the value of f of 6 to the nearest thousandth. So this is a problem that's like working backwards because they're giving us the derivative. So this graph, which again will not be given to you, I just wanted to give you something to look at, but this is this graph. And this doesn't really tell me much other than this is the slopes of whatever f of x was. So we've got to work backwards to figure out what was f of 6 in the original graph. Okay, so anytime I want to take a derivative and go backwards to what was f of x, you've got to do antiderivative or the integral. Or integrate. Because otherwise this doesn't do me a lot of good. And the best way I can explain it is, let's say this is water in a lake, the height of it. This would show me all of the slopes saying, okay, this was losing water, then it's positive, it's gaining water, and then the rate starts to slow down and it starts losing water. That's great, but it doesn't tell me how high the water level is unless I know this initial value. So this is crucial. Kind of like your money. If you had the stocks and you saw it going up and down, that's great, but it doesn't tell you how much money you would have unless you knew originally what money you put in the account. Okay, so what I would do is go ahead and go to y equals, I gotta clear out everything I put in before, x squared sine of 3x. Okay, and if you wanted to graph it, here's what it looks like, which almost doesn't look the same, but it had to get zoomed in. So now what I would do is I need to find the antiderivative. So I'm going to go math. Option 8 was derivative. This is what we have been using in derived. Now I want to do the function integral. Integrate. That's 9. Then it comes up with this integral symbol. I want to go from, and actually, we don't even need to put this in. Let me clear out of that. This is going to be easier. Let's go ahead and go math again. 9. That'll pull up our integral because we actually just want a number here. We're going to go from x is 2 and then x is 6 because these are x values here and here. We're going to put in our antiderivative. So our f prime, let me write this down so you have this for your notes, dx. Okay, and so I have that in. If you did not have that in for y1, you would have to type it in. But I'm going to again go to variables, over to y variables function y1. And then I want that dx. So I'm anti-deriving my derivative, which will get me the original. Now the thing is, that does not do anything with this original value. So recall that when we had a table and I had values, so let's say this is 2 and this is 6, I had to know that this is my rate of change. So I start at a y value of -6 and then I'm decreasing by this amount. So then I would end up subtracting. But really what you need to know, this is the fundamental theorem of calculus, is that you have the initial value plus the integral. So I'm actually going to have the y value of -6 plus this. You could do it all at once on your calculator. So I could have had -6 plus and then do this part, and that'll give me my final answer. Yep, it should be about -13 point something, or think of it this way on your table like we did. But your final answer should be -13.543. So again, it's saying you started with this as your y value. This finds you the change. It's really finding the area under the curve, but it finds the change from those x values, and then you apply the change to your starting value and it gets you the final value.